Szanowni Państwo, dla Państwa wygody podzieliliśmy Stormwater Poland 2026 na 4 sesje tematyczne. Powiedział już trochę o tym pan prezes Tomasz Grochowski. Pierwsza sesja zatytułowana Dekada wody rozpocznie się już za chwilę. Będzie to bilans doświadczeń ostatnich 10 lat. Od pierwszych systemowych działań przez popełnione błędy, aż po rozwiązania, które dziś mogą stanowić punkt odniesienia dla kolejnych miast. To także przestrzeń refleksji nad tym, jak zmieniało się postrzeganie deszczówki z problemu technicznego w kluczowy element bezpieczeństwa, jakości życia i odporności miast na zmianę klimatu. Jako pierwszy w tej sesji zaprezentuje się nasz gość zagraniczny, uznany na całym świecie ekspert w obszarze urbanistyki odpornej na zmianę klimatu oraz błękitno-zielonej infrastruktury, od ponad 4 dekad prowadzący pionierską działalność, kształtując koncepcję miast gąbek i promując transformację wody w mierzeniu się z wyzwaniami środowiskowymi, łącząc funkcje ekologiczne z innowacjami technologicznymi oraz ekspresją artystyczną, pan Herbert Dreiseitl.
Thank you so much to invite me. It's a pleasure for me and it's an honor to be here in Poland to talk about stormwater management. And I would like to share with you our experience, not only mine, it's also of all our colleagues who have been fighting for finding better ways and new ways how to work with water. And I would like to take you on a journey first, not as typical engineers to look at data and so on, but more to look really at water itself. I find it very, very fascinating to look at water in different landscapes and to see how water behaves. Water behaves in a very interesting way. It's actually not going the straightest, always quickest way from A to B. It starts to make oxbows, it starts to delay, it starts to be slowing down. It's actually even doing things like starting to go backward. It starts to do all kinds of things which are in nature so important. For example, all our fish habitat needs always this diversity of flow in our rivers. And I like to show this also simply experiments to engineers and to my students, how interesting water actually behaves. And what can we learn from water? And that's why I'm not starting just with science, but I'm starting really with art and design. How is actually water acting in a landscape? How interesting is what we can learn from water when we look at water structures? When we see how actually sponge, when we talk about sponge city, which is a funny name, I actually don't like it so much because it's much more than only a sponge. When we look at landscapes which are combined water and vegetation, blue and green, how smart and intelligent is a self-organized system working? What can we learn actually from this kind of structures? When we look at our human world, what we created the last 200 years with industrialization all around the world, basically we ignored a lot of this kind of, I call it wisdom of water, and we made everything straight. We made it organized, logic, fast, quick, and efficient. We think it's efficient. In the long run, it's actually not. When we look at our cities and our urbanization, which is going on, there is a consequence of that. And I would just like to share very, very brief about climate change. When I'm looking back on all what we discussed about 20 years, the worst case scenarios we had in Germany, for example, are today even not the normal. It's always exceeding our forecast. And when we look at all the data, you are probably aware, Potsdamer Institute of Klimafolgenforschung and others, we can see the extremes are coming up more and more. And what are the extremes? The extremes is not just it's raining more, because the amount of water which is coming down is almost not so much changing, but the intensity is extreme. For example, we can see that on one spot, we have suddenly a lot of downpour, like a cloudburst coming down. On the other side, 5 kilometers away, drought, no water coming. When we look at places in Europe, unexpected, but now more and more brutal, like the Ahrntal catastrophic situation in Germany. Villages, farms wiped out, water took away all the land. In my own city, where I live, on Lake of Constance, in a beautiful area, our train station was flooded twice by a so-called 100-year storm event. No train could go. And on the other hand, we have droughts. The mayor just mentioned it, and the introduction from Thomas was mentioned it very clear. We have too much or too little. And the consequences of that means that we have to think. We have really to think, what can we do different? How can we actually come up with new concepts? What can we learn, and how can we actually not only repair a problem, but also how can we create new values? Because it's also an economical side of it. Sponge cities, and sponge, just to explain a bit how this word actually came back, started actually on many places, and the Chinese used it to make it more simple. It's basically to hold water back, to suck it in, to evaporate, to infiltrate. And it's very much about thinking about cities in a different way. Instead of getting water rid as quick as possible, to see the city as a kind of organism of water, of a water sphere, which can hold the water back. And it's very much about repairing basically what we have in our cities by thinking what nature actually does. If we look at the natural environment, most of the water is evaporating. Very little is actually running down. Quite a lot is infiltration. Agriculture is changing. If we look to urban structures, everything is actually going out very fast with all the pollution we add on water. And we have to find out a way actually to get it more intelligent and more smart. Well, a lot of countries around the world have seen this problem coming up. So in America, they called it low impact development. And it's basically all the same, bringing nature-based solutions or technology which we copy from nature back into our cities to make them more smart, more intelligent, more water resilient. And it can be done on many different scales. And I would just like to share some examples because it's very important. At the end, I would like to give you some 3 key points about what we can learn from all this experience and what you might be able to continue. There are lots of tools we can use. Basically, all the different techniques we have to filter, to store, to hold back, to have retention facilities, to have green roofs, to have swales in cities to hold water back. They have basically 2 reasons. One is to balance the water, to hold it back, to store it, to keep basically the quantity controlled. And the other one, which is also equally important, to control the quality. Because we can do a lot decentralized already to clean the water, to filter, to have all this material we have in the soil with microorganisms to digest all the pollution we have basically in stormwater. We can treat it already on site, and that's extremely important. But how can we do this? How can we actually manage it? And I would like to just to share some examples on where we had experience, where we have been learning a lot. Large cities like Stuttgart or Hanover, Kreuzberg, for example, was a very interesting example. I was working with Seeker on this project. Basically starting where the rain hits the ground. That is the first action point where we can already do something. With vegetation, with green roofs, with swales, to collect the water maybe on the surface, not to hit it into the ground too much, to keep it relatively with little gravity on the surface, to hold it back on kind of cascading swales. When they get flooded, you can control a lot of stormwater and hold it back. This is actually a photo I got of a 100-year storm event, 2002 in Stuttgart, where a lot of places in Stuttgart were flooded, nothing in this area, because we could manage it. Or to do it in a way that it's not only a reservation for stormwater management. The added value is it can be a playground, it can be anything else, but it can also be a retention facility. So that is a very important part, I think. What we have to learn as engineers or as planners, we always have to see it multifunctional. We have to work with different disciplines, with city planners, with traffic planners, with landscape architects, with engineers. Everyone talks about it, but it's very hard to do so. And it's a learning process and a learning curve which is still on the way. We have not actually, to be honest, found the final result yet. Some cities are doing better, and I just showed some examples. Copenhagen, for example, the cloudburst concept, we worked on this a long time. Hamburg, the RISA project. There are many other cities as well. I take here as an example the city of Singapore, which is very much in demand of keeping water and holding water back. And it's actually very much what we are trying to do is here, not to have a single project, but to have a network of lots of opportunities to handle stormwater in the city. And that actually has to be any opportunity. How to convince government organizations, and it's not just if a mayor is actually convinced, it's actually you need the population to be convinced to give you political support and also finally also financial support. It's very important to do pilot projects. One of the pilot projects I was working on was Bishan Am Mokyo Park in Singapore for basically a green park, a very boring park with basically a canal, a main canal where water is shooting out into the ocean. We changed it completely and made a kind of stormwater park to keep the water in the facility, in the park. When it starts to rain, this can be flooded. And it's actually working like this. When there's a lot of rain, this area can keep the water, and when it's dry, the water goes down, and actually you can use it again. Sounds very dangerous. Yeah, and we discuss, of course, a lot about danger and about this, and actually you can imagine in Asia, in Singapore, they are even more hysteric than often we are in Europe. But it's interesting, it's not dangerous, because when it starts to rain, water goes up very, very slowly. There are warning signs, there are places where people actually step out and keep the place for water. And that's another learning thing. We should not in future, because of all the dramatic situations we have with the climate change, we should not guarantee always that we put everything underneath on pipes. We have to find ways to say in extreme conditions, even a road can be flooded, controlled in a way so that we are safe and that it doesn't flood other places like houses or damages buildings and so on. And it can be done, it can also be done on small scale or in large scale. Jakarta, for example, lots of problems in the city, but they're starting to go also this way. Or another example in Singapore where it is in the public domain. From all the neighborhood buildings and streets, the water actually gets into one park where there's in the middle a water lake here. It can be, but most of the time it's actually almost dry. And when there's a big storm, the water level can go up and can buffer and can slowly and clean go then down into the rivers and into the streams. It has to be very, very good communicated with the public. Everyone has to learn about why have we to do this? How can we have a better partnership with water in a city? In Singapore, we call it the ABC water guidelines, and even a taxi driver should be able to explain the system to a foreigner, and it works. Or architects, they can do so much more to work on green roofs or on structures. When you do it right, then you can activate actually also city planners and architects to come up with better solutions to make really interesting hotels to keep the water back. But now I go back to Europe, because you might say this is a dreamer, because somewhere it can be done, but not here in Poland. I show a very extreme example here now in Finland, in Oulu, on the north, very much on the north, a little bit south of Rovaniemi. Very cold winter conditions. The same system. We capture here all water in a new housing estate, in a new housing area, and we have green areas and corridors where the water can be filtered, where we can bring it in, and only if it's a big storm, then the water can run out on the surface. Of course, it works in the winter as well. The winter conditions are always an interesting point, but water is running off when it starts to melt. The difficult
part is always between freezing and melting. We can maybe discuss this a little. We had very, very good examples, very good experience there, and people really love it. And it has to be simple and beautiful so that people can accept it. We can also do so much more on our highways, on our roads. And actually, we're working on different scenarios on big roads, for example, in Europe, on highways, to treat the stormwater runoff from the street, to filter it, to have biofiltration, and to have basically swales where particles can be filtered out. And it can be very, very efficient. That's the way how to go. And then finally, I would just like to show some examples which are more in a denser situation in the city. A very interesting example was when we united East and West Berlin at Potsdamer Platz. Of course, we had the opportunity also to work with water in a different way. So what I was very keen of is collecting every drop of stormwater on the site, clean it, store it, even recycle some of this water. We have big tanks in the basements, basically kind of basements where we had car parking and leftover corners which would not be able to use for cars. And we could bring the water there and actually recycle and reuse the water from there for all irrigation we have on Potsdamer Platz in Berlin. It's basically an open basin, and I don't want to say that this is a model which can be done everywhere. That's an extreme example, but it's actually to use the challenge of rainwater and of stormwater and to use it as an opportunity to make even added values for a city. Today it's a very attractive place. Water is shown, is celebrated. Of course, we have filter systems included to get rid of nutrients and phosphorus in water. And we also save a lot of drinking water because by recycling on that. And I go even a step further because it can also be done in industry much more, where we have often big surfaces where we collect water and we basically just get rid of it as quick as possible. And what a waste of resources. If we can recycle and reuse water also from big areas on industrial sites, we can do better. I show an extreme example. This is for the car factory for McLaren in London, where I had the chance to work actually also on experiments here with Norman Foster's office. And what we do is we collect water from all the different rooftops and we bring it into a kind of buffer cistern and we circulate the water and we use it as a cooling system for the entire plant. So the factory, the energy and the heat load is actually brought out by cascades and bringing technique and aesthetic actually together. This is the overview. We also collect the water, of course, from car parking to collect the runoff of car parking, filter it, treat it, and recycle and reuse it. Maybe at the end, I would like to show a bit more, again, in a more dense city, in an existing city. If we have the opportunity to do a kind of restructuring or renovation of a city, stormwater treatment and sponge city solutions should come in right from the beginning, and it needs a kind of strategic plan. Portland, Oregon was one of the first cities in the US. I was actually working a lot in Portland on the main concept, and we had some pilot projects, and one I'd like to mention here to show. This is actually the Tanner Springs Park. Basically what we do on this is one plot in the city, and what we do is basically we collect water from rooftops, from streets, from sidewalks. We bring it into a kind of multifunctional park, which is filtering and treating the water in a way that it's a kind of filtration and cleansing thing. And then finally we store the water where the level can go up and down. And some of that is actually also circulated, and then it goes down actually into the river. And to do such things in the city, you have to get the population, of course, involved. So participation or talking about stormwater solutions with the public domain, with people, is extremely critical, extremely important. And people are willing to follow because everyone understands that the climate issues are getting more and more extreme, and we have to do something for now, but also for future generations. So this stormwater park and stormwater treatment is more than just a treatment park for water. It's also an interesting space where people can enjoy. It's a park, people can go there. The water level can go up and down, so sometimes you cannot use it, but other times you can use it. And I would like to end my presentation with 3 slides on some findings, which I think are also, for this conference, may be interesting, because I want to give it more like a keynote opening for further discussions. I think one is a very important point is about policy making. These slides and these pictures look all nice, and everyone thinks it can be done somewhere where people have a lot of money. But it's not true. It can be done everywhere, and it is not a matter of being rich. It needs a strategic plan. It needs actually a very clear vision for a city. Where do we want to be in 20 or 25 or 30 years from now? All the successful cities working with stormwater had a plan for the next 20 to 30 years. Copenhagen, Vienna, Singapore, New York City, Portland, and others. They were actually putting this on a very high agenda, a long-term vision plan for that. Secondly, you need to have pilot projects. And pilot projects actually have to be in front of your doorstep in the city. Because I hear this argument all the time. Yeah, it can be done there in Finland or in Singapore, but not here, because we are different. Everyone says the same word. And that's why you need something close to your place, or a good example, for example, in Poland, where you can say, that's how it looks, that's how it is maintained, that is how it performs. And that's actually very important. And finally, what is also needed, we have to be much more smart in finding fundings and financial, the whole aspect of funding projects. Because it's not just a matter to fix a problem, it's actually also a matter about creating more value. For example, of these parks, what I just have shown, we try to get the stakeholders and the companies who are around there on board to invest into the project, so we have a better funding. Or in case of Singapore, we try to get traffic planning, park planning, infrastructure, the different funding budgets together to one, and to go with one big lump sum or one budget forward for a plan. And by that, you can actually do many, many different actions. You can combine them, and by combining things, you can make them cheaper. You can make them more smart. This is very important to always combine things with, if there is a renovation going on in a street, then you have a chance to bring trees in, you have a chance to work with swales. But if you do only this, it's too expensive. So it has to be always combined and has to be very, very smart in the way to finance it. Next point, I would like to talk about takeaways about responsibilities, maintenance, or I just have to see if that is, if I'm too fast. I think I have to go back one here. Okay, I hope that's planning process, right. Planning process is, I think, very important in a way that we have to integrate infrastructure or sponge city concepts relatively early in the planning process. If you as an engineer or a landscape architect come in very late and all the layout of streets and everything is done, the heights are already done, you cannot do much, because then you have everything is already set, and then a stormwater concept cannot fit in, because it's a different approach. If you put pipes underneath, you can still fit them somehow, but if you work with surfaces, you are very much depending on the infrastructure on the surface, on the management of surface, on road and traffic systems, on buildings, on heights, on entrances of buildings and all that. It has to be combined. That's why stormwater management has to come in very, very early on the roundtable process of planning. Secondly, decentralized treatment. I think with my talk I have been showing that. It's not just one big facility. It's actually many. And they are more efficient because they also work in a time cascade. Because stormwater, when it comes down, it's not good to bring it all to one point where you have to treat it in one point. But when you have a timing cascading and hold it back and manage it in a more smart way, you can delay process. And finally, multifunctional systems and networking corridors, which are green infrastructures which are going through the city, where you say you have park connectors, you have swales, you can have gravity, and you can work city planning, and road planning can go together with future planning for management. Finally, maybe just to take this away, is the management and basically the responsibilities of that. That's also a very, very important part, because often maintenance and responsibilities are very strict, organized in silos in our normal business. And when we work with stormwater, and the examples I have been showing, there's always a kind of overlapping. There is an overlapping, for example, of maintenance service on roads, on parks, and on stormwater. And it has to be sometimes the same company. It has even to be the same team, and they have to be financed from different sources. And all that has to be extremely well organized and needs new concepts. Another one is that all these topics, what I'm trying to show, is always it goes from private property to public and never the other way around. Otherwise, you get in troubles. And maybe finally, to talk a bit about responsibilities and financing, I think I just mentioned this as a very, very big topic which has to be worked out right in the beginning, early on. And these are often somehow the biggest discussions where often projects don't go forward. And I think that's also something we have to be very much aware, and it needs a kind of clear leadership from the city. That's why these vision plans and these very clear strategic plans are important. So I think with that, I would like to end my opening as a keynote to give you some perspective on, or maybe some ideas where stormwater management could go in the future. And I just would like to mention that even I remember we have lots of my colleagues, and we have been working for more than 40 years in this direction. We are still feeling we are on the beginning, and we could do much more. So everyone who's working on this field is kind of bringing new examples, pushing the envelope, pushing the whole thing forward, but I think there is no way back. All the data we see on climate change are showing clearly that we have to find better solutions, and we have to create from a problem, we have to turn it around and to use it as a solution for smarter cities and more for livable cities as well. Thank you so much.